This is the beginning of putting all of our tools and all of our rules about circuits together. So our goal this entire time was to be able to solve combination circuits, circuits that have both parallel components and series components in them. So we're going to start by just solving a circuit for equivalent resistance. That's it. So having a circuit like this with some series components in it and some parallel components in it is a little bit more complicated to calculate the equivalent resistance of the whole thing. So here's where we start. I see two resistors over here that are obviously in the same branch. So any electricity, any electron that flows through one of them has to flow through the other one as well. And so that means these two resistors are in series with one another. Now, an electron that goes through this branch cannot also go through this branch, right? Let's just draw our paths really quickly. So here is one path. And here is the second path. So any electron that travels down the green path is going to go through R1 and R4 and R5 and R2, but it will not go through R3. Any electron that goes down the red path will go through R1, R3, R2, but not R4 or R5. And so that means that R4 and R5 are in parallel with R3 because they are not part of the same path, but R4 and R5 are in series with R1 and R2 because they are part of the same path. R1 and R2 are also part of the red path with R3. And so we have to be careful about the order that we calculate equivalent resistances in. We cannot go R4 plus R5 in series and then add it to R1 and then add it to R2. They are all in series with each other, that's totally true, but then you have neglected the fact that R3 is also in series with R1 and R2. So the first thing that we have to do is try to deal with the relationships that do not affect other relationships. Okay, so here's what I mean. For instance, R4 and R5 are in series with one another. So we can find the equivalent resistance here without affecting R3's relationship to R1, for instance. Okay, it will affect nothing else. So if I combine these two, that will give me a new resistor. I'm going to call that new resistor R6. So this is going to get very colorful and hopefully not too messy to follow. So this over here, this is a series component that I'm going to call R6. And R6 is just R4 plus R5. R4 plus R5. And the question says that all the resistors are 2 ohms, and so that means that 2 plus 2 is just 4. So R6 is 4 ohms. Okay, so I'm going to redraw this circuit now, reflecting the fact that I've taken R4 and R5 and I've combined them into one equivalent resistor called R6. So here we go. There's our new circuit with R6 having replaced R4 and R5. They are equivalent though, okay? So now I have the same two paths. My green path includes R1, R6, and R2, and my red path includes R1, R3, and R2. So I still can't go R1 plus R6 plus R2 because that would change my relationship with R3. Okay, but what I can do is take R6 and R3 and combine them in parallel. Then I have not affected R1 and R2 at all. So R6 is in series with R1 and R2. R3 is in series with R1 and R2. So if I combine these two things in parallel and create one equivalent resistor, that equivalent resistor will be in series with R1 and R2. We haven't changed that relationship at all. So that's what we're going to do. So we're going to take R6 and R3 and combine them into one resistor. I'm going to call it R7. R7 is in parallel, right? This is a parallel relationship, and so I have to use the reciprocal rule. 1 over R7 is equal to 1 over R6 plus 1 over R3. 1 over R7 is equal to, R6 is 4 ohms because it's a combination of R4 and R5. So this is 1 over 4 plus R3 is just a 2 ohm resistor still, 1 over 2. So this is 1/4 and 2/4, which is 3/4. And then I need to flip it upside down, right? So R7 is equal to 4/3 ohms, or 1.3 repeating. Okay, so now I'm going to redraw my circuit again, reflecting the fact that R6 and R3 have been combined into one equivalent resistor. So here we go. There's our new circuit. And notice now that this is a very simple circuit, that all three of these resistors are just combined in series. So R7 is a combination of R4 and R5 together in series, and R4 and R5 plus R3 in parallel. We've taken this section of the circuit and simplified it into one equivalent resistor. So now that we have one simple series circuit, it's very easy to add these up using the series rule. So our series rule, REQ, equals R1 plus R2 plus R7. Now you can use different notation for this R7 equivalent resistor. Some people, instead of writing R6, like to write R45 equals R4 plus R5, and then this one together would be R36 or something like that. However you want to make it clear is all right with me. So the equivalent resistance of the entire circuit here is equal to 2 ohms plus 2 ohms plus 4/3. And so my entire equivalent resistance now all put together is 5 1/3 ohms. Or if you like it in decimals better, 5.33. And we're done.